Hello, this is Mrs. Taylor, and I'm going to show you how to simplify square roots. So with square roots, you can use two methods. You can use the factoring method that's in my other video for simplifying radicals. Or you can use the method where you're looking for perfect square roots, or excuse me, perfect square factors. And so what I mean by that is the perfect squares are the numbers that you get by squaring another number. So if you square one squared, you get 1, so 1's a perfect square. If you square 2, 2 squared gives you 4, so 4 is a perfect square. And so the first few perfect squares are 1, 4, 9, 16, 25, 36, and so on. And so when you have a square root, sometimes it's quicker to look for a perfect square factor rather than trying to factor the number all the way down to its prime factor. So let me show you what that looks like. 28 I can factor a couple of ways. I can use 2 and 14, or I can use 4 and 7. But I'm going to choose 4 and 7 because 4 is a perfect square. So instead of continuing to factor, all I have to do is take the square root of 4, which is 2, and then leave the 7 in the radical. It's that quick. The math behind it looks like this. If 28 is the same thing as 4 times 7, sorry for my handwriting, and with radicals, I can separate those into 2, so that can become the square root of 4 times the square root of 7. And I can go ahead and take the square root of 4 to get a whole number, which is 2. And so that's preferable with the final answer. If you have a perfect square factor, you want to go ahead and factor it out and take the square root for your simplified answer. So this will be the simplified form of square root of 28. Now that you know the math behind it, you don't have to write all that out. So, in other words, 50 can be factored several ways, but I'm going to choose the factoring of 25 and 2 because 25 is a perfect square. The square root of 25 is 5. So really quickly I can get to the simplified form by recognizing that and just rewriting it as 5 square root of 2. And so those are your basic square roots that you'll be asked to simplify. And then of course you could throw in some variables. And so in these two examples, it just so happens that they're both perfect squares. The square root of 144 is 12. The square root of 36 is 6. But you also have to simplify your variables. And if it's square root, if there's no number here, it's understood to be a root of 2. So you divide 2 into the variable. And so 6 divided by 2 is 3. And so that means that the square root of p to the 6 is p to the third. And then if there were any leftovers, so let's say if this is p to the 7th, 2 would go into 7 3 times. So you have a p to the third on the outside of the radical. But then you have that one p left over. And that p would stay inside the radical. So I'll show that in just a second. So square root of 144 is 12. And then 6 divided by 2 is 3, so that becomes p cubed. Square root of 36 is 6. 34 divided by 2 is 17, so that would become q to the 17th. And what I was saying earlier is if I had something like this, square root of 144 times p to the 7th, square root of 144 is still 12. 2 goes into 7 3 times. But I still had that 1 left over. So that remainder stays inside of the radical. So the simplified form of square root of 144p to the 7th would be 12p cubed times the square root of p. And so that's how you would simplify square roots.